What values of x plus y could equal 8? There's lots of values that could equal 8. 1 plus 7 could equal 8. 2 plus 6 could equal 8. 3 plus 5 could equal 8. 4 plus 4 could equal 8. There's so many different variations of numbers that could equal 8. You could even get into decimals, irrational numbers, fractions. However, if I add on x plus 2y equals 10, then one more y has added on 2 more to our answer. So, a single y has to be equal to 2. If I follow this through, that means that x has to be equal to 6. So that 6 plus 2 equals 8, and x plus 2y equals 10, with 6 plus 2 times 2 equaling 10. These are simultaneous equations, two equations which have to be solved at the same time, so that we can actually work out what two different variables are. There's three types of ways to solve simultaneous equations. Substitution. Graphically, where you draw two lines from your equations, and your solution is where the lines cross. Or, if you're a fan of dancing on ice or the X factor, you can eliminate something and get rid of one of your variables. Our first example is going to be 2x plus y equals 13 and 3x plus 4y equals 37. Now, what you have to do first is label your equations. This makes them easier to work with so you know which equation you've eliminated or moved. Now we're going to rearrange this equation here, number 1, because y is on its own. So rearrange equation 1 in terms of y. This means y equals, and in our case y is going to equal 13 take away 2x. What do I do with this now? Now that I know what y is equal to, I can put it into my other equation in place of the y. So substitute our new equation number 3, remembering to label it, into equation number 2. So my new equation, which was 3x plus 4y equals 37, is going to become 3x plus 4 lots of 13 take away 2x, which still equals 37. Our goal here is now to expand our brackets, so 3x plus 4 lots of 13, which equals 52, and 4 lots of minus 2x, which equals minus 8x, and that still equals 37. So if I tidy this up and collect like terms, I get minus 5x plus 52 equals 37, and with a little bit of rearranging, I get down to x equals 3. Now that I know what x is, I can actually substitute my value of x into either of my two equations to find out what y is going to be. Either works. I'm going to choose number 1. So 2x plus y equals 13. 2 lots of 3 plus y equals 13. So 6 plus y equals 13. Y has to equal 7. So there's both of our solutions. And these are the unique solutions for both examples. In our second example, x plus 4y equals 49 and 3x plus y equals 26. We're going to rearrange either of these two equations, because at this precise moment, x is on its own and y is on its own. I'm just going to pick equation 1. So we're going to rearrange that in terms of x. So equation 1 is now going to be rearranged to say x equals 49 take away 4y. This is going to be equation 3. So, we're going to substitute equation 3 into the equation we've not used, which is equation 2. So, equation 2 started life as 3x plus y equals 26, and is now going to be 3 lots of 49 take away 4y plus y equals 26. So, we need to just expand our bracket. So we get 147 take away 12y plus y equals 26. By collecting like terms and rearranging, we can get a value of y, and we get a value of y equaling 11. Again, what we're now going to do is take this value of y and put it into either of our two equations. So we're going to substitute y into either 1 or 2. I'm going to choose 1 because it makes it much easier to work with. So x plus 4y equals 49. X plus 44 equals 49, so my value of x has to be 5. So there's the unique solution for both equations.